Hello everybody and welcome back to Elementary Statistics Online at Frederick Community College. In this video I will start talking about inferences on two samples. So this is chapter 9, which is really continuation of chapter 8, where we discussed hypothesis testing, but in this case we're going to talk about two samples. Okay, and in the first video I will talk about inferences on two means where we have independent samples. Okay, so samples that have nothing to do with each other, and the outcome of one does not affect the outcome of the other. Okay, all right, so I'm gonna go ahead and set up the following problem. Okay, let's say I have scores for the midterm, class A, and all scores for the midterm in class B. And the data that I'm going to be using for this example is an actual data that I've collected for my statistics classes. Okay, and it's all in my calculator already stored. So let's go ahead and come up with the characteristics of my data set. I'm going to do one variable statistics for class A, which is stored in L1, and that gives me the following information. I have a sample mean of 77, okay. My sample standard deviation, let's take a look at that, is 18.2, and my sample size here was 37. Okay, all right, so here's class A. These are real numbers. For one of my classes, I have 37 students. Sample mean for the midterm score was 77 with a standard deviation of 18.2. Okay, let's go ahead and do the same thing for my other class. One variable statistics, L2. Okay, what did I get here? Sample mean is, let's go ahead and call it 64. Okay, 64 for the sample mean. Sample standard deviation is 25.7. Let's erase that. 25.7. And how big of a class was this from? That was a class of 40 students. Okay. All right. So let's take a look at these numbers right here. If we compare the means, you will see that class A had a higher mean and a lower standard deviation, which means, okay, let's see, on average, this class did better. And a lower standard deviation also means less spread, right? So there were a lot less variation in the scores. They were a little bit more bunched up than this class right here. Okay, both samples are large enough for me to conduct hypothesis testing. But what is my main question? What am I really trying to figure it out here? Okay, so my goal is to figure out if class A did significantly better on the midterm, right? We can see that the numbers are different, and 77 is greater than 64, but is it significantly different? Is it significantly bigger? That's what the real question is. Okay, let's go ahead and do hypothesis testing. So the first step in any hypothesis testing is always to set it up right. The null hypothesis versus the alternative hypothesis. Okay, the null hypothesis will always say the two means are the same. Or you can also see it saying mu1 minus mu2 is 0, meaning there is no difference between the two. Okay, this will always be the case for hypothesis testing on 2 samples. All right. Okay, now what about alternative hypothesis? Well, that really depends on the problem and how you set it up. So in my case, I'm wondering if class A did better than 64. 77, is that higher than 64? Yes. Is it significantly higher? Well, that's what we're going to find out. Okay, so really I'm testing this claim, is mu1 greater than mu2, or mu1 minus mu2 is equal to 0. Okay, either one of these will be correct. Okay, so that's the setup that I'm going to use. Now, this part is really important. It's important to set this up right, and one way to check is actually take your numbers and say the following: is this true? Is x1 bar greater than x2? And the answer is yes. 77 is greater than 64. The question is it significantly greater? But that's one way you guys can always check if your setup is right. These numbers should not contradict the alternative hypothesis. Otherwise, you're going to get the wrong answer. Okay, what's step number 2? Now we need to figure it out what test to use. Now, I will not be using by hand computations. You can read about it if you would like, but really, we're going to do all computation on a calculator. The question is, which test are we going to use? Well, I have 2 samples, and each sample has a sample standard deviation. So I will be using 2 sample t-test, okay? Because we don't know sigma 1 and sigma 2. These 2 are not given. Okay, whenever we have sample standard deviation, just like in chapter 7 and 8, S means t-test. Sigma means z-test. Well, we don't have sigma, so we have 2 sample standard deviations. So we're going to be using 2 sample t-test. Okay, all right, so where would I go? So we're going to go to stat test. 2 sample t-test is command 4. Okay, so let's take a look. All of my numbers are already here, right? So let me just go ahead and delete that real quick. Okay, so now let's plug in our approximated values. Okay, 77. And we said 18.2 here. Okay, the sample size is 37. Okay, let's go ahead and make this 64. Let's see, 25.7 and 40. Now the reason I'm doing this, because typically you will not have the data. You will have all of the summaries. Okay, so you will have sample mean, standard deviation, and sample size. I have the whole data, so I could have used all of those characteristics already, but let's just say we don't. That's okay. You just plug this in carefully. The next step is to choose the right option on this line right here. Okay, now that's why I'm looking at this line right here. Okay, and what did I set this up to? Mu1 is greater than mu2, so I have to highlight this part right here. Okay, mu1 is greater than mu2, and notice that I have 77 for x1, x bar 1, and 64 for x bar 2. Okay, that's also important. They need to match. And then pooled, always say no. Let's go ahead and calculate. So I got a p-value of 0.006. Okay, 0.006. So p-value 0.006. Okay, now I didn't give myself alpha level, but that's okay. Whenever alpha level is not given, what do? We just assume that alpha level is 0.05. So 0.006 is a lot less than 0.05. That's alpha level 0.05 by default if it's not mentioned to you. Okay, so what does that mean? Now we gotta write a conclusion. The conclusion here is to reject the null. reject the null hypothesis. There is sufficient evidence to claim what? To claim that class A did significantly better on their midterm than class B. Okay, this is basically saying 77 is significantly higher than 64. So now what? As an educator, what would I do? I say, okay, I have this evidence. I gotta go back and see what was different. Okay, why is this difference so big? Okay, why did class A do a lot better than class B, and what can I do to avoid this situation in the future? Really, hypothesis testing is about decision making. Okay, yeah, we run some numbers, we crunch some numbers, we come up with a conclusion, and now what? So in my case, I gotta take a look at 2 of my classes and say, all right, I did something here and I didn't do it here. Let's make sure this is done again, or depends on the situation, right? So now I need to come up with a plan to improve scores for class B. Okay? All right, so that's your hypothesis testing. What else can we do in this situation about this particular problem? Hypothesis testing tells you if there is a difference. Now, what about confidence interval for the difference of 2 means? So let's go ahead and run this real quick. Confidence interval for the difference of 2 means. Difference between 2 means. Okay, how is that different from hypothesis testing? Well, they're really kind of giving you the same information, just slightly in a different way. Hypothesis testing tells you if there is a difference. When there is a difference, confidence interval tells you what that difference is. Okay, so I'm going to run 2 sample t-test. Not t-test, 2 interval. We'll just run the test, okay? And write an interpretation for it. So 2 sample t-interval. Let's go ahead and go back to our calculator. We're going to go to stat test, and we're going to find 2 sample t-interval. The interval, no. So it's command 02 sample t-interval. Now, once you run the test, the data is already in it. So, okay, we're going to do L1, L2, yes, frequency. You can just skip that. You say 1 and 1. And then confidence level. Well, if I used 0.05 as my alpha level, then it makes sense if I'll use 95 here, right? Okay, and I'm going to go ahead and compute this interval. Let's see what we get. Okay, let's call it 3.10, 23.2. Okay, 3.10, 23.2, right? Let's take a look again. Yeah, that's good. What is my interpretation here? Okay, I am 95% confident that the true average difference of midterm scores is between 3.10 and 23.2 points in this case, right? Okay, so again, hypothesis testing and confidence interval really tell you the same information, just kind of in a different way. Hypothesis testing tells you if there is a significant difference. The answer here is yes, there is a significant difference here. Okay, let's write this yes nice and pretty. Yes, it is different. By how much? On average, by this much. Okay, so 95% confident that the actual average difference is somewhere in this interval, so between 3.10 and 23.2 points. Okay, notice that there is no zero in this confidence interval. That's good. That is consistent with hypothesis testing rejecting the null hypothesis. Okay, so let me run through this again. We have an inference on two samples. The two samples here are independent. Okay, one good indicator that they are independent if the sample sizes are different. That's one really good indicator. They don't have to be, but if they are, you know for sure these are independent samples. Okay, sample sizes are large enough for us to run the hypothesis test and confidence interval. We don't have sigmas, so we do two sample t-test. P-value is small, that means the difference is significant. Okay, we'll reject the null, and then we'll run the confidence interval to show us where the true difference is contained. It's contained between those two values. Okay, all right, thank you for watching. The next video will be about two proportions.